we're going to continue our discussion of basic integration techniques. Some of these you may have seen before and some of them not. The biggest thing is we would like to, when we look at an integral problem, know how to start it and then be able to evaluate it. So we're just going to jump right into some examples. All right, when the degree of the numerator is greater than or equal to the degree of the denominator, we're going to divide. So if you look at this problem right here, notice the degree of the numerator and the denominator are both the same. We would not do a u substitution on this one because the du would be too big. We don't want to do a trig substitution because I have too much going on in the numerator. So that's when we would use this trick, which is we're going to divide. So if you remember long division, that's exactly what we're going to be doing. We're going to be taking the denominator and dividing it into the numerator. And if you remember from just normal long division, we're going to follow that same process. So I'm just going to be looking at this number right here, or value right there, and I'm going to think to myself, x squared times what would be 2x squared, and I know that that number would be 2. So remember, in long division, we'll now take 2 and we'll multiply by what's outside, but we actually have to multiply it by both things. So we are going to get 2x squared, and then we will get plus 32. Okay, if you remember, the next step in long division is to subtract, and I'm actually going to subtract both of those. So you'll notice 2x squared minus 2x squared gives me nothing, and then 0 minus 32 is going to give me negative 32. All right, so I'm going to write down what I have. My x squared plus 16 went into 2x squared 2 times, and then I have my remainder, so the way that we're going to write a remainder is minus 32 out of how many I started with, which was x squared plus 16. Okay, please notice that we now have two parts, so I'm going to have two integral expressions. So that was our goal, was to be able to find something that we actually could take the integral of. Now the integral of 2 is 2x, and the integral of this one, just from doing the other problems that we did in the first video, I noticed that we can do a trig substitution. It's going to be an arctan problem. My 32 I don't really need there, so I'm just going to bump out front. I'm going to put a 1 in its place. So if I identify my parts for a trig, if you recall, trig is, I'm just going to rewrite it again just in case you are not familiar with it. So that's the formula that I'm referring to. My a value will be 4 because remember, a is the constant. My u will be x, and that makes my du, the derivative of x, is 1, which I have, so I have all my parts. So I'm going to have 2x. I'm going to bring down my minus 32. My formula says 1 over a, so this is going to be times 1/4 arctan u over a. And then I'm just going to simplify because 32 times 1/4 is 8. So my final answer is going to be 2x minus 8 arctan x over 4 plus c. So that would be my answer. Just one comment. If I came down to a part right here, and I know you're going to have a couple on your assignment, if I came up down to something here and this x squared would still go into this part that I had left over, I would just continue the process of long division. So I wouldn't necessarily stop right there at one step. I can just keep going. All right, the next one, it is called my multiply by e to the opposite sign trick. All right, if I look at this right here, I have 1 over 5 minus e to the x. We've been taught usually if there's a denominator, we're going to let u be our denominator. But if we do that, du would be e to the x, and I do not have an e to the x up in the numerator, so I'm stuck. So if we have an e in the problem and we're stuck, we are going to multiply by e of the opposite sign. So notice there is an e to the positive x in our problem, so we're going to multiply by e to the negative x, but obviously we can't just multiply something by e to the negative x, so I'm also going to divide it by e to the negative x, and then let's just see what happens. So if I multiply the numerator by e to the negative x, I will get e to the negative x, and then if I multiply the denominator by e to the negative x, I'm going to distribute to both parts. 5 times e to the negative x will be 5 e to the negative x, and then minus e to the negative x times e to the x times e to the negative x. That would give me e to the 0, which would be 1. Now notice I really set myself up so that I can do a u substitution. So that's why we did that trick. All right, so now I'm going to let u be the denominator like we're used to doing. Okay, du, the derivative of 5 e to the negative x minus 1 will be negative 5 e to the negative x. Notice I have the e to the negative x now, just missing the negative 5, so I'll put a negative 1/5 on the outside, and then from there I'm going to have negative 1/5. I just found out that this is my du, and then the denominator is my u. And then if I have the integral of du over u, I know that that's equivalent to natural log, so this is going to be negative 1/5 natural log of u, which is 5e to the negative x minus 1, and then plus c. And we got it. So we turned a problem that we couldn't do into one that we could. All right, trig identities. All right, some different trig identities that you will want to be familiar with. The first one I'm going to write down is sine squared x plus cosine squared x equals 1. And then another identity that we will want to know is secant squared x plus 1 is equal to tangent squared x. And I need to double check to make sure that is right. Nope, I am wrong. Okay, we are going to redo that. This is actually 1 plus tangent squared x is equal to secant squared x. All right, so those are the two identities we want to be familiar with. So if I look at this problem right here, tangent squared 3x, I know that there's not a formula for an integral for that. Doing a u substitution is not going to help me out. So I'm going to go to this trig identity right here, which has a tangent squared in it. And I notice I'm going to basically replace tangent squared with what it equals. So I'm going to solve this for tangent squared. Tangent squared x is going to equal secant squared x minus 1. So if I come up here, I'm going to have, and obviously since this says 3x, I'll put a 3x in place of the x. So I'm going to rewrite this as secant squared 3x minus 1. And since I have a minus sign, I'm going to separate it into two separate problems. Okay, now doing this first integral, I know that the integral of secant squared u du is equal to tangent u. Okay, so I notice there's a formula recognition. I just need to pick out my u. So my u is going to be 3x, and that means my du, the derivative of 3x, is 3. Missing the 3, so I'll put a 1/3 on the outside. So this is now 1/3 secant squared of u. I now can use this formula, which I know the integral is going to be tangent, so I'm going to have 1/3 tangent of u, which is 3x, and then minus the integral of 1 is x plus c. So once again, I was able to get to an answer. All right, final little technique we're going to have is something that's called multiplying by the conjugate. All right, I see this problem. Doing a u substitution won't help. Don't know any trig substitution that I can do. So we're going to apply the multiply by the conjugate technique, which is to multiply the numerator and the denominator by the conjugate of the denominator. So the conjugate, if you remember, of 1 plus sine x would be 1 minus sine x. And obviously we have to do that to the top and the bottom so that I'm not really affecting the problem. Okay, up top, when I do 1 times 1 minus sine x, I'm going to get 1 minus sine x. And then down below, I will have to FOIL. I'm going to get 1 minus sine x plus sine x minus sine squared x. Okay, and then I'm going to have 1, this is an integral of course, 1 minus sine x over, these cancel, so I'll just be left with 1 minus sine squared x. And then I'm going to look at a trick that I had written in a previous example. We had sine squared x plus cosine squared x is equal to 1. So I kind of am seeing something's going on with this. I'm actually going to replace it. If I solve this, cosine squared x is equal to 1 minus sine squared x. So it was just kind of noticing that that's involved in an identity somehow. So I can replace the denominator with cosine squared x. All right, and now I'm still kind of stuck. So what I can do, since there's a minus sign up top in the numerator, we can apply our trick, separate the numerator. So I'm going to separate the numerator at this point in time. I'm going to have 1 over cosine squared x minus sine x over cosine squared x. All right, so now I've created two problems for myself. Let's see if we can solve them. All right, in problem, this first one, 1 over cosine squared, that doesn't help me, but I do know that 1 over cosine squared is equivalent to secant squared. And I do know a formula for secant squared. We just used it in the previous problem. It is equivalent to tangent x, so that problem is solved. All right, for the second one, I do notice that I have a power in the denominator, so I'm going to let u be the part without the power. So I'm going to let u equal cosine x, and then du, the derivative of cosine, is negative sine x. And notice I do have sine x in my problem. I'm just missing the negative. So I'll put a negative on the inside and a negative on the outside, which will turn that to plus. And so now I have plus the integral of du over u squared. And that is not equal to ln because this is a u squared, so I'm going to bring that up top. So now I am going to have tangent x plus the integral of u to the negative 2 du. And if I take the integral of that, if I increase my power by 1, I'll have u to the negative 1 times the reciprocal, which would be negative 1. So this is going to be tangent x minus 1 over u, which is 1 over cosine x plus c. And then we're going to be real fancy and we're going to go one more step, and I'm actually going to bring my answer way up to the top. I'm going to have tangent x minus 1 over cosine. We already found out a little bit earlier where it's equal to secant, and then plus c. So voila, we turned a problem that we were unable to take the integral of in the first place into one that we could. We got to do lots of steps and use lots of tricks to get there. So hopefully you had as fun as me doing that problem. So hopefully now you can evaluate integrals using some basic integration techniques.